Hey everyone, here's our math problem for today. Let's begin with this yellow circle O and this rectangle ABCD. From each corner of this rectangle, let's draw a line segment that is tangent to the yellow circle at point E, F, G, and H. The length of segment AE is given to be 33, segment DF is 35, segment BH is 85, and we do not know the length of segment CG. Let's call that as X. We would like to find the value of X. You can pause the video and see if you can solve this beautiful geometry problem. Now let's solve this problem together. Let's begin by recalling that when we have a line segment that is tangent to a circle, that line segment is also perpendicular to a radius of the circle. So let's draw this right triangle. OE is a radius and that is perpendicular to the tangent line AE. Since we have here a right triangle, we can apply the Pythagorean formula. The square of the sum of the two legs with a measure of 33 and R is equal to the square of the hypotenuse AO. Similarly, we can draw this other right triangle, and from Pythagorean formula again, we have 35 squared plus R squared equals the square of side DO. Then, for this right triangle here, 85 squared plus R squared is equal to BO squared. And finally, for this other right triangle, x squared plus r squared is equal to the square of the hypotenuse CO. Then let's replicate this figure, and this time, let's remove all these tangent lines. Instead, let's draw this right triangle. Let's think of AB as the base and AD as the height, but this length of this right triangle here is just part of the base, so let's call it as base of 1, and the remaining segment here as base of 2. This height here is h sub 1, and the remaining height here we will call later as h sub 2. Now from the Pythagorean formula again, since we have here a right triangle, the sum of the squares of the two legs, b sub 1 squared plus h sub 1 squared, is equal to the square of the hypotenuse AO. And do the same thing for this other right triangle. Here, this base is the same length as that, so let's call this as b sub 1 also. This part here is also b sub 2, and the height is h sub 2. From the Pythagorean formula again, this is the equation that we can come up here. The square of b sub 1 plus the square of h sub 2 is equal to the square of this hypotenuse DO. Similarly, we can draw again this other right triangle, and from the Pythagorean formula, we have b sub 2 squared plus h sub 1 squared is equal to BO squared. And finally, we have here another right triangle, and the resulting equation is the square of this base plus the square of this height is equal to the square of this hypotenuse CO. Now, let's put these two sets of resulting equations side by side, and notice that the right side here and the right side here at the other side are equal respectively to each of these equations, which means that their corresponding left members are also equal, resulting to this set of equations, and let's call them as equations 1, 2, 3, and 4. We have variable x, variable r, variable b sub 1, b sub 2, h sub 1, and h sub 2. So there are 6 variables, and we only have 4 equations. But notice that by elimination, we can pair these equations together like this and subtract equations 2 and 1. This r squared and r squared will result to 0. This b sub 1 squared and b sub 1 squared will also result to 0 when subtracted. And so what we have is 35 squared minus 33 squared equals h sub 2 squared minus h sub 1 squared. Let's call this as equation number 5. Then in here, subtracting equations 4 and 3, again, r squared minus r squared is 0. B sub 2 squared minus b sub 2 squared is 0. So the difference is x squared minus 85 squared at the left side. At the right side is h sub 2 squared minus h sub 1 squared. Let's call this as equation number 6. Look at this right member here, and look at the right side of this equation here also. Notice that they are exactly the same. So since quantities that are equal to the same quantities are also equal, then this left side here is equal to the left side of the other equation. And this gives us now an equation containing only the variable x. And so we can now find the value of x by simply solving this equation. So solving now for x squared. X squared is equal to 35 squared plus 85 squared minus 33 squared. And from the symmetric property of equality, we interchange the left and the right side of the equation. So 35 squared is 1,225, 85 squared is 7,225, and 33 squared is 1,089. Performing the arithmetic computation, we have x squared equals 7,361. Take the square root of both sides. We have x equals plus or minus the square root of 7,361. But since x is the length of a line segment here, then x cannot be negative. So we just take the principal square root of 7,361, which is approximately 85.796. And so this is now the value of x in this problem. So x is approximately equal to 85.796. So this is indeed a beautiful math problem for students to practice their algebraic skills and their knowledge of the properties of geometric figures.